And here's the new part. So if, it's finishing 4-2, if you have an isosceles triangle, what will be true that we know if it's an isosceles? What will already be true? Two sides will be the same, and what else? All right, and then we have this line. We'll call this line AB. And this line AB is an angle bisector up here. What does it mean to be an angle bisector? It cuts that angle into two equal angles, correct? Then, this is what you can tell me. Not only is that line AB an angle bisector, but it is actually a perpendicular bisector to this other side. When I say AB is an angle bisector, when I say AB is an angle bisector, what am I talking about? I'm really talking about angle DAC, and I told you that AB line segment cuts that in half. You follow me? When I tell you that AB line segment is a perpendicular bisector to DC, now I'm talking about this line segment over here, and I'm telling you that it intersects at 90 degrees and cuts it in half, and cuts this angle in half, and these two angles are the same. So it kind of creates two identical reflected right triangles. Does that make sense, yes or no? All right, well, how can we use this? All right, tell me some other stuff that you know. Tell me some other stuff that you know. Why? Yeah, but did I tell you that this is an isosceles triangle? Brody? Did I tell you it was a perpendicular bisector yet? Mm-hmm. But I didn't tell you that that triangle was an isosceles triangle. When is this angle bisector only going to turn into a perpendicular bisector? When we're dealing with a what type of triangle? Did I tell you that it's an isosceles triangle yet? Hey, there's two ways I could have told you that. What's one way I could have told you? Call them tick marks. I could have put a tick mark between A, B, very good, and what else? Then I would have told you what kind of triangle do I have. Now this B to D is a perpendicular and a bisector. Do you follow, yes or no? What other thing could I have told you? Yes. Assuming it's not good, probably. AC? Yes, once we approve this is a isosceles. But what's another way I could show that this is isosceles? Besides the tick marks, there's one other way. What else has to be true for an isosceles?
Writing the equation and saying this is an isosceles.
Yeah, they could say it in the verb or in the verbiage of it. What? What if I showed you that these angles would be the same? Then this has to be an isosceles, and now you can start to fill in all this stuff. And yes, Brody, if this is 14 and this is 14, then this whole thing has to be 28, right? That's that line segment addition postulate that we talked about a while ago. Yes? Now how can I find H? Well, what kind of bisector was this? Which means it intersects at a what kind of angle? And then if I draw this, maybe this will help you figure this out. What theorem can you now use to help solve this? Go ahead, do the Pythagorean theorem. You should probably have a calculator.
I don't remember what happened when the hypotenuse is.
Let's set this up. A squared or H squared. Does everybody at least understand that part now? Put this in your calculator. That just means 14 times 14. What'd you guys get? Equals, what's 16 times 16? And then what am I going to do? H squared equals. Now what do? No. What is the opposite of squaring something? And then we get, technically, when you put the square root sign in there, and I want you to practice this for algebra 2's sake, when you put the square root sign in there, you actually have to put plus or minus here. And then how do we do the square root? We're going to learn a different way to simplify this very soon. But for right now, I want you to learn how to simplify it on a calculator. How do we put it in the calculator? You're going to hit the number 60 in your calculator right now. You're going to then hit the shift button.
7.745. The 7.745.
And then you're going to hit the x squared button, because right above it there should be that little square root symbol. What happened when you did that? You got what?
7.6 or 7.74596666.
All right. So we're going to round to the nearest tenth. So this is going to become h equals 7.7. Why did I get rid of the negative? How come I'm not going to keep the positive or negative anymore?
Because it's distance.
It's distance, and when we talk about distance, we're only going to refer to the positive. But let me tell you, if I just put this up on the board, and you have no idea what I'm referring to with x, and you square root this side and you square root this side, x equals, what would be your answer? No. Who put the square root sign in there? You did. What do you have to put in front of it then? Plus or minus 5. Remember, what was the real question? What number times itself is 25? That was the original question. Now, watch this. Look at this. It's a little different. What if I just say, what's the square root of 25? What is your answer? 5. What's the difference between this question that's up there and this question that's right here? Do you see how there's already a square root as part of it? Then what did I not put in this one? Plus or minus. Do you see how there was no square root? I put it in there. I put it in there. So guess what I have to put? Plus or minus. That's how I remember it. All right, try another one. Since this is an isosceles triangle and QS is an angle bisector, what else does it make QS when it compares to PR? Perpendicular bisector, which means it intersects at 90 degrees, and these two are the same. Well, how does that help me out? Well, they wanted me to find R, S to Q. They wanted me to figure out the measure of that angle. Well, if this is 90, what does this side have to be? And if this is 31, what does this angle have to be? Why? If you look at the big overall, you see the overall? And that whole big, so these angles or the base angles have to be the same. So if I know that's 31, then what am I going to do? 90 plus 31 plus, we don't know, so we'll just use x equals 180. What's 91 plus 1, what, plus 31? And we minus 121. And we get x equals what? What'd you get? Everyone agree to that? Now, if this is 4, we said that this was also a bisector. So if this is 4, what does this have to be over here? But then what does that mean PR is? The entire distance across. What would PR be? Yes or no? All right, equilateral triangles real quick. What do you know about equilateral triangles? All sides are the same. And what else? Yep, and what are the angles actually? If they're all the same angle, we would take 180 and divide it by what? When you take 180 divided by 3, you get, so every angle is 60 degrees. I really think that we should be able to fill in every one of these angles. If you think about it. What kind of triangle is ABC? What does that mean the measure of this angle is here? What is the measure of this angle? What is the measure of this angle? And then they tell me the measure of CBD. Is what? So if this whole thing is 130, what does that make this little piece? Does everybody understand how we figured that out? And isn't that what did they ask me for that? What angle did they ask me for? Which is BDE. AD. They asked me for the measure of this angle, correct? Well, what kind of triangle is ADB? Isosceles. And these two angles are my what? And my base angles, right? They're equal. So if I take 180 and minus what from it? I get 100 and then I divide it by 2 and get the measure of angle BAD is what? Does everybody get how I did that? Good? I'm going to give you a little more time on this one. Try it by yourself so you can start applying this stuff. $72. Find the measure of angle U. Let's go.